So here we're really interested in trying to figure out how we can improve virtual reality and reduce cyber sickness, not by adding odors and so on, although we haven't tried that yet, but by really improving the locomotion interfaces. And we're especially interested in doing this without reducing presence or any of the other usability factors that are critical. So why flying in VR? I mean, the first time I was able to fly through Vancouver in an embodied way without having to use controllers, that was really amazing. It almost felt like a flying dream. But of course, as you know, it comes with a lot of challenges. So it's kind of a worst case locomotion challenge. You have to control all 6 degrees of freedom. Visual-vestibular Q conflict is a lot higher. People love to go really fast and high speeds and accelerations and brake and go up and down. So it is a challenge. So what do you do? I mean, the standard, as you know, continuous locomotion, it works, gives you a nice sensation of actually moving through space, which helps with spatial orientation, but it can make you sick. Teleportation, the other extreme, basically, let's get rid of all the locomotion, self-motion cues, just teleport you. Of course, that also gets rid of cyber sickness, but at a cost, as we all know. And now the question is, can we combine the best of both approaches, give you some predictability of continuous locomotion while also removing the worst of cyber sickness? And there's a few ground-based approaches that people have tried, including our HyperJump one, but it wasn't really clear how to translate this to more naturalistic flying in actual 3D space. So the question here is not so much, okay, which is the winner? Because there isn't one. It really depends on your purpose, your susceptibility, all of this. The question is more like, okay, what is the cost and what do we need to optimize for? So how do we really reduce cyber sickness without giving up too much presence, self-motion, and control? So to do this, we compared 4 different systems: continuous locomotion, manual teleportation, and the 2 HyperJumps that I'll explain in a moment. So for continuous locomotion, literally use a controller, control it continuously. Here's a beautiful part of Vancouver. We added some snowflakes so you get more optic flow. Get the idea. Manual teleport, we first had to design a system that actually allows you to really predict where you're going. So we have this little mannequin, gives you size cue, you know exactly where you are, and then each time you press a button on the other controller, you teleport there. And as you can see, people did this really quickly sometimes, so it was quite amazing. We tweaked it quite a lot. Now, automatic HyperJump, that's the first version we have. Where you would potentially get sick, then we, instead of allowing you to go faster, we jump that distance that you would have traveled. And you can, of course, disable it. And the idea was really to give you the size cues. Now, this was really great for exploration, so we have hundreds of people explore it. Within seconds they could use it because you don't need to learn anything in addition. But from what the users told us there was that, well, we want more control. When we go somewhere specifically or faster and so on, so we added the manual one where you basically, each time you press the trigger, you jump. And again, people actually did this at quite some speed. We were impressed how quickly they could pull the trigger. So we did this in a Virtual Vancouver version, thanks to GeoSim Cities, and of course thanks to my student Kenneth Garthik, whose master thesis that is, fortunately can't be here today, and others also contributed, of course. So kind of like a gamified racing through space task. So you had to go very specifically here. If you missed it, you were teleported back, try again until you hit it. So it's quite a hard task. You use snap rotation and up and down, and every few stops we also ask to rate things. So here's the layout. We had tutorial practice of that and then different places, and every now and then you were asked to rate. And then the ratings, so we asked for, okay, do you get sick or not? And then, oops, sorry. Okay, do you get sick or not? And we then followed up with a 0 to 10 scale, so adapted from Bernhard's version of the fast motion sickness scale. Also asked for disorientation, task difficulty, and then based on all the pilot testing, we added a leadership score. people love to compete. So this is Kenneth, and people are trying to beat him in terms of performance. So it was fairly, on purpose, a fairly demanding task. For interfaces, lots of behavioral measures, including temporal aspects, SSQ. Of course, after the session, we had various in-VR ratings on sickness, dizziness, spatial disorientation, and so on. User experience, task load, and a quite detailed open-ended interview that I won't have too much time to go into. Experimental design took overall about 90 minutes, so tutorials, all of this, and then basically 3 segments with ratings in between. And after you were done with one locomotion system, then we did the additional ratings there. So what did we find? So basically, in terms of the time taken, what we saw is that the automatic HyperJump version actually took longer. Kind of made sense because it's harder to control and you cannot quite go as far as before. And that was the case both for the training and for the main trial. However, if you looked at the other measures like missing targets, waypoint errors, we didn't really find any significant differences between these different measures. Now, if you look at cybersickness, overall cybersickness was relatively low. We did, however, see some trends, as you can see, for the continuous locomotion. The was a little bit higher, it was significant for the disorientation score, but overall it wasn't super high. However, if you asked people to just simply state, are you getting sick or not, definitely a much higher percentage reported getting sick for the continuous motion. And similarly, if you ask them for the sickness and dizziness question, continuous locomotion was rated the most sickening, and the manual teleport versions the lowest. If you look into self-motion or vection intensity, it was highest as predicted for the continuous locomotion. Interestingly enough, for the teleport, people still reported some self-motion, which kind of doesn't seem to make sense because you're teleporting. But as you've seen, they teleported so quickly that it almost was a slideshow where you got apparent motion. So they still reported some self-motion, for some people actually quite high, so individual points. And the HyperJump, as we kind of hoped or predicted, was kind of in between. So you got more of a sensation of self-motion than with just a regular teleport, but not quite as high as for the continuous, which makes sense because the optic flow velocity was at least a factor of 10 or so lower. So it really makes sense. Now let's look a little bit more into the self-motion cues. So how does this really relate to other measures? So we see that vection really, so higher vection correlated with a reduced breaks in presence, so less breaks in presence if you get more vection. Also increased overall presence. Plausibility was also increased. However, dizziness also went up a little bit. Not super high, but a little bit. Motion sickness, there wasn't a clear, significant correlation. Now, if you look also at presence and immersion, then what we see is that presence was the highest for the continuous locomotion, which is the most natural one, and lowest for the, if you maybe most artificial one, the pure teleport condition. And the HyperJump was again kind of in between. So definitely higher presence than pure teleport, but not at the level yet. And if you look at the believability, similar pattern, more believable with continuous and also less breaks in presence for the continuous locomotion there. If you look at the post-experimental ratings, so what can we learn from that? So I've asked a lot of questions. Here's just a few of them. So nearly half the participants said the different contexts really changed their rating. So basically, depending on where and how they would use it, they would change their ratings quite a bit. 72% said they would switch the interface if given an option. Here we didn't give them an option because it was a study. And also they felt that fun really led to more presence in there. They also felt that enjoyment really affected cybersickness levels. And 85% reported that reported breaks in presence and often related to the teleportation or jumping, which kind of makes sense. And there's a lot more in the thesis, especially on the interviews. So we did thematic analysis. I won't go into this, but there's a lot more in the thesis if you're really interested what people really think and do and the reasons they have. What I'd like is to, is that a downward timer?
Yeah, 5 minutes.
Okay, well, actually, I can briefly go through that. So, in terms of presence, the continuous locomotion really felt more immersive, but also increased cybersickness. For the cybersickness itself, I think the key part is really that the continuous locomotion was the main issue, and some people adopted strategies. Like they literally closed their eyes during the fast movements, and they really tried their best to do this. So, in conclusion, so the continuous locomotion interface, clearly it's well known, so people don't have to train or practice. Most of our people had a lot of experience with that. Good for presence, vection, immersion, believability, all of these kind of things, but you get sick. If you have a tendency to get easily sick, sure, manual teleport works really well, although the HyperJump has an almost equal benefit in terms of reducing cybersickness. It's also well known, so that helps a lot, but it has the known disadvantages that we confirmed in terms of naturalism, believability, immersion, presence reduction. Now, automatic HyperJump worked really well for exploration tasks, but not so much if you want to go somewhere very specifically at really extremely high speed. So there it wasn't that well suitable. However, that's where the manual HyperJump actually worked relatively well. So it did a decent balance. It kind of reduced sickness almost as good as the teleport, but immersion, agency, presence, and so on was at a better level. And like one person mentioned, for example, that it really offered more control while still having enough immersion. Lots of other interesting feedback if you really listen to the users. Like the leadership board really helped to get them excited and motivated. Their music they liked in terms of their overall user experience. So some of them really wanted to spend more time in there. Key thing is really that controllability, predictability, and immersion matters a lot. Depending on the context, depending on the users, what state they're in, what they'd like to do really. And clearly we shouldn't try to reduce one aspect, not cybersickness, not presence, but really depending on the specific task requirements, what people need to do. And also it was very clear that our users wanted more agency. So also the context, the task, where they're at, even within a trial, they often wanted to switch. So there's clearly no overall winner, and they want really the ability and agency to do this. And this, I think, where the hybrid works quite well, because we also explored giving them the agency to see, like, okay, at what time, at what velocity do you start hybrid jumping, and so on. So this, I think, is quite promising. There's always more work to do, of course. But one key finding is really the personalization, flexibility is important. Questions, of course, well, based on what? The actual task, user preference, symptoms, expertise, system-driven, user-driven, all of that. So basically, what should we optimize for and in for? If you'd like to know more, here's a link. My website is currently not working, but I'm always interested in collaborating, continuing with this, interested in students and so on. And thanks. I think I made it in time.
Yep.